Welcome to aminacademy.com. In physics, regarding potential, let us do some solving problem. Look at these examples. How much work is required to carry an electron from a positive terminal of 12-volt battery to the negative terminal? Here, you have to calculate work required to carry an electron in positive terminal of 24-volt to their negative terminal. First, for this voltage required, therefore voltage is given minus 24 volt. That means from negative to the negative terminal, and therefore W work required is QV. Q is charge of one electron, that is minus 1.6 into 10 power minus 19 into minus 24, which gives 2.8 into 10 power minus 18 joule of work required to carry one electron from positive terminal to negative terminal of 24 volt battery. Next, here, how much electrical potential energy does a proton lose as it falls through a potential drop of 10 kilowatt? Here, how much electrical potential does a proton lose if it falls through a potential drop of 10 kV? The proton carries a positive charge. It will therefore move from region of high potential to region of low potential if left free to do so. That is, it automatically comes. Its change in potential energy as it moves through a potential difference V is VQ. We need change in P, change in potential energy of electron equal potential energy of proton is equal VQ, where V is minus 10 volts, minus 10 into kilowatt, 10 power 3 kilowatt, into the charge of one proton is positive 1.6 into 10 power minus 19 coulomb. So it gives minus 1.92 into 10 power minus 17 joules required. That is, that electrical potential energy does a proton lose its falls through a potential drop of 10 kilovolt. We need the work, that is potential energy is equal to minus 1.92 into 10 power minus 17 joules energy required. Next question. An electron starts from rest and falls through a potential rise of 120 volts. What is its final speed? Here, an electron that is starts from rest, initial velocity is 0. Potential charges tends to fall through a potential drop. Negative charges such as the electron tends to fall through a potential rise. That is potential rise of PE equal VQ then that is here that now we know that potential energy is the kinetic energy, which is equal half m half m vf final square minus half m v initial square. Here, final speed, what is its final speed that falls through a potential rays? What is its final speed? Here, initial is 0 here. Then we can say 1.92 into 10 power minus 17, which is before that you have to calculate the VQ. 120 Q is 1.6 into 10 raised to 19. 1.6 into 10 raised to minus 19 coulomb, which gives minus minus here, therefore minus 1.92 into 10 power minus 17 joule. This 1. Minus 1.92 and 10 power minus 17 joules is you are using here, that is potential energy, which is equal half m mass of one electron, half m is 9.1 into 10 raised to minus 31 kg into Vf square. Now by using cross multiplication, Vf equal minus 1.92 into 2 into 10 into minus 1.92 into 10 power minus 17 over into 2 over 9.1 into 10 power minus 31. That is mass of one electron. Here you can use for the calculations to become positive, since it is here minus comes through the square root. We have the final velocity is 6.5 into 10 power 6 meter per second. Therefore, speed of the electron when it falls, the potential rise of 120 volts. What is its final speed? This much. Final speed is 6.5 into 10 raised to 6 meter per second. Next question. The 4 point charges are placed at 4 corners of the squares, 50 centimeter on each side. Find the potential at the center of the square if the 4 charges are each 5 microcoulomb. Then first one, A, for if the 4 charges are 5 coulombs. Here, look for one. We will draw one square. Here, with the four charges of 4 point charges are placed in for positive 5 microcoulomb. 5 microcoulomb, 5 microcoulomb, 5 microcoulomb charges. Here, which is equal V equal K times sigma Q over R. Here, K is 9 into 10 power permeability, 9 10 power 9 Newton meter square per coulomb square into Q by R is 4 times, because 4 equal charges, 4 times 5 into 10 power minus 6 means microcoulomb. 5 microcoulomb is 5 into 10 power minus 6 coulomb, and 4 is equal because both sides equal, and each side is 50 centimeters, 0.5 meter. So divide by 0.5 into cos 45. Since this diagonal is because it's a square, the diagonal makes an angle 45. So at the center we have to calculate 0.5 into cos 45 is that from the center to the one corner distance. So which gives the value 5.09 into 10 power 5, 10 power 5 3.4 into 10 power 5. That is 5.09 into 10 power 5 joule, volts required. 4 points is kept each corner of the square, then final at the center, the total voltage is 5.09 into 10 to the power 5 volts. Next question. What is the, from here we have to calculate second part and 4 charges of these 3 coulombs, 3 microcoulomb, minus 3 microcoulomb, minus 3 microcoulomb, plus 3 microcoulomb. Therefore, the total net voltage is in second part. Net voltage at center of the square equals 0. Since this addition of plus 3 minus 3, therefore sigma voltage here, since voltage is 0, since V equal to 0, net voltage is at center is 0. Since total coulomb is minus 3 plus 3, therefore sin sigma q equal to 3 minus 3 and plus 3 minus 3 equal to 0. Sigma q equals 0. Therefore, total voltage is 0. Next one, what is the speed of 500 electron volt of proton and alpha particles? Here, remember, here kinetic energy is equal to potential energy. Then half mv square equal 500 electron volt, that is 500 into mass of one proton, potential energy, that is kinetic energy is half mv square, is directly kinetic energy will be 500 into mass of one proton is 1.6 into 10 power minus 27 kg divided by 1 electron volt, 1.0 electron volt. Here 500 electron volt, 1 electron volt. Therefore, from this, half mv square equal from this directly we can find velocity v equal, this 2 will go up, that is 2 into 500 electron volt into 1.6, not 27, it is mass of one proton is proton here, that is minus 19. 1.6 into 10 raised to minus 19 over this is Coulomb charge, one proton charge is 1.6 into 10 raised to minus 19 over the mass of one electron is 1.67 into 10 power minus 27. This is Coulomb, this is mass kg. Then, which is equal 30.952 into 10 power. Here minus 27 go is plus 27, minus 19 plus 27 is 10 power positive 8, just square root 10 power 4, half of 8, which is further equal 3.0952 into 10 power 5 meter per second, the speed of one proton. If alpha particle is proton and alpha particle, speed of the 500 electron volt alpha particle. Now we are calculating for alpha particle. We know that alpha particle is 4 times the mass of electron, mass of proton, times the mass of one proton. Therefore, same, the velocity is equal square root of 2 into 500 into 1.6 into 10 power minus 19 Coulomb over 4 times, m is 4 times there. Here 4 times 1.67. 1.67 into 10 power minus 27. Then which gives 15.476 into 10 power 4 meter per second, which is equal 1.5 into 10 power 5 meter per second. Look at here. Here, that speed of one proton is 3.0952 in 10 power 5 meter per second. Speed of proton is half of the speed of alpha particle is half of the speed of one proton, because alpha particle's mass is 4 times then 4 times than the one proton. Therefore, speed of the alpha particle is half of the speed of one proton at same conditions. Therefore, which is 1.5 into 10 power 5 meter per second. So far we discussed about some solving problem regarding potentials. We have done. Please subscribe our YouTube channel.